Lesson 1.6, segments and their measures. Okay, remember the segment addition postulate says, and we don't have to write out the whole thing, but I'm going to draw a little diagram, and maybe we can kind of summarize that segment addition postulate with a little diagram. And let's call this X, Y, Z. And so our segment addition postulate would say that XY plus YZ is equal to XZ. That's what the segment addition postulate says. And so now we should be able to find these missing pieces because of that. And so this one, if I kind of took a little bit of a shortcut here, what I might do, let me call this X. Since it's a missing thing, let me just call it X. And I'm going to say 39 plus X is equal to 75. And so if I subtract 39, then I'm going to get my answer. And my answer is going to be, I might need a calculator here, but X is 36. And you could kind of check it by adding these together. And it's 39 plus 36, 75. Use your calculator. It is. All right, similar thing here. I'm going to call this X, and I'm going to say 8 plus X is equal to 57. And now I'm going to solve this. I'm going to subtract my 8, and I'm going to get X is equal to, again, might need a calculator, and I get 49 on my calculator. And once again, we can put this in and see if it works. We can check it. 8 plus 49. Is 8 plus 49 57? Put it in your calculator and see. It is. It's 57. Okay, part of geometry is drawing the points and being able to read a sentence and trying to figure out how to put that sentence into a diagram. And so that's what we're going to practice here. A, B, and C are collinear. Point B is between A and C. So B is going to be in between those two. So in other words, if I draw a line, I'm going to have point A down here, point B somewhere, and point C down here. Notice I didn't put B smack dab in the middle, and I did that on purpose because it might be in the middle, but it might not. And if I draw it that it looks in the middle, I don't want to confuse you that way. Okay, it says that AC is 52 and BC is 14, and we're trying to find AB. So it looks to me like our equation is going to be x plus 14 is equal to 52. And now I just need to subtract 14 to solve my equation. So that's going to give me x is equal to, and I'm going to put this in my calculator, and I'm going to get, I believe, a 38. And so once again, if I put 38 here, I could check it. Is 38 plus 14 52? I believe so. All right, next one is following the same rules. So I'm still going to have my A here, and my B here, and my C here. It says that AB is 27, and BC is 28. Find AC. That's an easy one. I bet you can do that one. Can you find that real quick? Okay, hopefully you got 55 on this. You put this in your calculator, 27 plus 28, put it in your calculator, and you get 55. So these were pretty basic because it was just like a single number and a single x and what have you. Sometimes in geometry we start putting these other variables and stuff in there, so our equations can start getting a little bit more complex. They're not harder, they're just a little bit more complex. And so it says find the value of x and then find the indicated length. Okay, well, how are we going to do that? Well, we know the segment addition postulate, and the segment addition postulate says that HG plus GF is equal to HF, right? That's the segment addition postulate. So now I can plug in these things in there. So in other words, HG, I have 3x minus 18. I'm going to put that in parentheses just to avoid confusion. And that was 3x minus 18. I think I said it wrong. That's 3x minus 18. GF is negative 4 plus 2x. And again, I'm going to put it in parentheses so that it's all together. It needs to be together. And HF, that one's 13. Okay, so now I need to go back to what we learned last week. And we learned about combining like terms. And so I have a 3x and a 2x that I need to combine. That combines to be 5x. I also have a negative 18 and a negative 4 that I need to combine. Do that on my calculator, and I get negative 22. And I'm going to bring down my equals 13. So now I just need to solve this. So I'm going to add 22 to both sides. And so 13 plus 22 is 35. Divide by 5, and I get 7. So here's what I like about this class, is that we just learned about solving equations last week. And now we're practicing it, and we have like a context to use it in. And that's why I like this class, is it puts those things together so we can see why we even need equations. Well, here's why we need equations, for example. Okay, another one. Similar thing. I'm going to start off with my segment measures. So I have a TS and an SR is equal to TR. All right, TS is 6 plus x. SR is 13, and TR is 5x minus 5. Okay, so again, we have an equation here that we need to solve, so we have to put our like terms together. And on this one, we have like terms over here with a 6 and a 13, so that's going to give me a 19. I still have my plus x, and I'm going to bring down my 5x minus 5. Okay, so I can go either way, and usually I like to keep my variable on the left, but since it's just a plain old x, I think I'm going to subtract it the other way. And remember, when you do that, what you're really subtracting is 1x. So we have 19. X minus x drops off. 5x minus 1x is 4x, and I'm going to bring down my minus 5. Almost done. I'm going to add that 5 to both sides. And take a second to add those together. So that gives me a 24 is equal to 4x. And if I divide by 4, I get 6 is equal to x. And again, we could check these by putting them into the diagram. So in other words, if I put a 6 up here, that would give me a 12 over here and a 13 over here. And if I put a 6 in this one, that would give me 30 minus 5, which is 25. And then I can check and see, is 12 plus 13 25? Yes, so I did it right. Okay, let's turn the page. We have some more examples. More examples on this page, but this time they don't have a diagram, so we have to draw a diagram. Points A, B, and C are collinear. I don't know which one's which yet. Point B is in between A and C, so B is here, A is here, C is here. BC is 9. AB is 2x minus 6. And the whole thing is x plus 12. Find x, and then find the length of AC. So this is actually a two-step problem. Part A is to find x. Part B is to find the length of AC. I think we can do it though. So if I put these together, I'm going to have 2x minus 6 plus 9 is equal to x plus 12, right? Because that's the two smaller parts add up to be the whole big one. So if I add my like terms, I have 2x, negative 6, and positive 9. We combine those together. That gives me a 3. And then I bring down my x plus 12. I need to solve my equation. I have x's on both sides. I'm going to keep all my x's on the left this time. So I'm going to subtract my x. 2x minus x, remember that's like a 1x, so 2x minus 1x is 1x plus 3, and I bring down my 12. I'm going to subtract that 3 from both sides, and I get x equals 9. And once again, we could plug it in to check it. So if I plug in a 9 here, I would get 21. If I plug in a 9 here, I'd get 18 minus 6. What's 18 minus 6? That looks like 12 to me. So is 12 plus 9 21? Yep, I did it right. Okay, last problem. Once again, they don't give us a diagram, so we need to draw a diagram. It is really, 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 really hard to do these without a diagram. I think I'm going to say you have to draw a diagram for this class. So it says R, S, and T are collinear. R is between S and T, so R is between the other two. And so you can't tell that just by going in order at the beginning. You have to actually read that sentence to figure that out. Okay, now they say that SR is 3, RT is 4x plus 1, and the whole thing is 8. So I need to add my two smaller pieces and set it equal to my larger one. Okay, there's a couple different things I can do here, but I think I'm going to add my like terms so that I have 4x plus 4 is equal to 8. I'm going to subtract that 4, and I get 4x equals 4. Divide by 4, and I get 1. So I can put a 1 in here, and that would give me 4 plus 1. Well, 4 plus 1 is 5. Here's a 3. Here's an 8. 3 plus 5 is 8. That does work. We've got it right. Okay, that was lesson 1.6. We will work on this in class tomorrow.